Hello squirrels, welcome to the SquirreledGameDev, and today we're starting with the next episode of our Like a Dream project. In the previous short we talked about the main ideas for this game, so if you haven't seen it yet, please go and check it in the card above. Alright, so in today's video we're focusing on the first major element, the movement. But before we start, I would like to show you the basic project structure I made before the stream, so we could start with the main content right away. I really spent hours on thinking about the way to show the more advanced code to noobs like you in programming, so I want to put a disclaimer here. It's not a tutorial, I will not explain to you every single line of my code. I'm gonna focus more on the effects and on the logical way I got to achieve them. It's gonna be something between a tutorial and the code bullet. If you've got any questions, just post them on my Reddit. Got it? So let's go with that. We are now in our Codesandbox. If you want, go to the link in the description to see the preview and the current version of my code. We're coding in React and using Canvas to draw. On the left you can see the folder structure. The main file is index.js. Here we render the whole website structure. We're using context to easily provide variables to every single component in a project. Inside we render the menu component. Now the functional menu doesn't exist, but later we'll be able to make it here. For now, we render the game instead. This component is just a builder for our game. We store all of the game details in the context. So, as I said before, we are able to use it in every single component in the project. An example, we can delete the previous game details in the menu. In this return down here, we render the game you see on the right. Basic lookout and positioning is specified in styles.scss file. There we initialize the game rendering function, which is going to invoke the game loop. Yeah, every single game and program works in the infinite loop which draws the next frames of the game. And the speed of passing next iterations of the loop is called FPS, which stands for frames per second. In our words, the number of iterations in a second. There we also have the function which scales the game when we resize its window. And this is the main loop with a time delta and drawing functions. If you want to know something more about them, just watch the How to Make a Squirrel Jump video where I explained more. Above we've got W and H functions calculating responsive distances based on the window size, and mid X and mid Y, which let us keep a thing we draw in the middle of the canvas. In the main loop we launch some helper drawers like player and falling subs to make the code cleaner and organized. In the player module we'll calculate and draw things connected with the main character. I split this into a head and a body, so it will be easier for us to animate it in the future. In falling subs, however, we will draw the falling collectibles on the paths you can see on the board. In the assets folder up here we put stuff like frames, backgrounds, fonts, etc. And that's it. Now we are prepared to look at what happened on the stream. I already made, so when we want to click the head, it says that we are in the head. When I click the body, it says we are in the body. When we click outside of this, it says nothing. So that means we are on the right track to make it. It only checks that we click this. If we click it and we move somewhere else and drop the mouse button, we see that it didn't count the click event, yeah? So that only counts the click inside the square, but we don't want it. We want it to see that the mouse is inside, the cursor is clicked, and that it isn't dropped. So I started with making a reusable function that checks if the cursor is inside of the character. It is very useful for us because later we want to make it possible to drag the character. I also explained to you which conditions it needs to check to know it. This point, which coordinates are cx and cy, we know that it intersects the rectangle when we have one point and two sizes of the edges. So we are on this axis, so if position of this point plus size of this edge is wider than position of this point plus other conditions for this edge too, that means we are inside the rectangle and there's no other option. Then we need more left mouse button event listeners. For dragging we need 3 of them. On mouse down, on mouse up and on mouse move. Now we need to check if the cursor is dragged or not. I created a variable called isInsideHead when clicked, which keeps one of the 3 states, not tested, inside and outside. But wait, do we really need a not tested state? No, we only need to know if it's dragged or not. We know we are dragging something when mouse is both inside the element and we are moving the mouse. Let's implement it. The next thing is that we need to move the character when dragging it. For that we calculate the offset we're gonna add to the character's base position. By offset I mean the difference between the current cursor position on x-axis and the previously registered position, and that difference we need to add to the previous offset. As you can see, it works, but it's not perfect when we move the mouse quickly. However, that's a bug for another episode. Bye!